DDS supports three mainstream of installation sources divided by their medium type. Also mentioned by Marcus, apart from electrical, we have sanitary for fluids and like sewer, cold water systems, also included with heating. And our third discipline is ductwork, everything which has to do with calculating ventilation. Well, I prepared a little project for you which was intended as an intelligent building model. As you can see right now, I've opened my DDS screen in my discipline, and I would like to show you the building model which is reused from the model. As we can see right now is a IFC model in which certain intelligence is already present. The IFC file is split into levels or into stories, so we can identify the information from within this IFC file. When I look inside this room, for example, we can see this room is called entry, so this is the entrance of the building, and this file will be reused inside DDS with intelligence. Representing from the ground floor inside DDS, this is the imported file in the function of creating the building model from the IFC file. As we can see right now, the complete building model is similar to the building model inside the IFC file. But inside DDS, the architectural model needs to be enriched with information which can be used for building services. So this model is imported inside DDS, and when I open up a setting of the model itself with all stories, we can see identical to the building model. So this is the IFC file as a representation in Celebi Viewer, and this is the model which we will use inside DDS. When I now open up my ground floor, we can see the information inside is splitted on different levels, and we can also see from the levels on V0 and V1 there are also rooms included. And for doing building services or for doing installation parts, it's very important to know what not only the name of the space is, but also what the function of the space is. From the building model, when I open up a detail, for example, in this kitchen area, there are certain specifications or certain functionalities needed for this area. When I double-click on my room list, the naming of each room is listed with a corresponding unique numbering, and the capabilities of DDS is that we can add information to this. So for us, the kitchen is not only a kitchen, but we can also say, when we look inside the kitchen, that we also have a specific heat load. And the heat load is a result of a calculation based on European standards, but also the result needs to be confirmed with the specifications of the kitchen itself. So what we can do, we can reuse the information from this kitchen and say, our kitchen in 20 square meters needs to have a temperature setting on 20 degrees. So the function of the kitchen is now mapped to the room, which is also called kitchen. And let me see if I can press OK. And this function of the room can be seen for each of the different spaces which are available in this story. So we can see that our kitchen is now heated as a 20 or 18 degrees temperature, and our toilet also applies with 18 degrees, and we can also see a technical room which is non-heated. So for the information which is now added into the building model, we can reuse the information and also use this kind of information for making the calculations available. All right. Inside this IFC file, we are using different objects which are recognized by DDS. Talking about heat load, there are a lot of information which is needed inside the room itself. So it's not only the name of the room, but it's also the values of the walls and doors and windows which are applied in the building model done by the architect. So we can see that the information is recognized from exterior walls and also recognized for interior doors and windows. So the information is directly reused and can be applied by a calculation directly on heat load. We can have a very big scope on the model. So if we look to our heat load overview of this model, we can see in total this building demands almost 19 kilowatts on heating, and this can be seen every step more into detail. So if we open up the room list, we can see inside the overview of this particular story, and if we open up the kitchen itself, we can also determine what the heat load is causing, and also the heat load can be determined on each specific object. So the relations of the building model and the relations of the spaces and their corresponding U values and also their result as a heat load can be investigated into detail. So for example, this underfloor heating floor has a specific heat load in which the U value is calculated within DDS, or we can say we would like to use a specific parameter or a specific value for this effective heat load. Of course, the information can be printed in different reports in different formats. So one of the reports is that we can have, according to the European standard EN 12831, we can open up such a report. I will click on the report. The report is generated in the background of DDS right now. So I will show you the report in just a click. I would like to include different values from this report. And when I click OK, the report is generated with different pages. First of all, on the report, we can see an overview of the building itself. So this is our report now generated, 9 pages in total. We have the overview of the building, and from each space we can go into more detail. And at the end we have a summarize of the building information itself. So, of course, the heat load is also relying on where this building is located. So if we look to the location, in this case I used a location in the Netherlands, but as we can see we can have different locations, and from my experience and also from the experience of Carolus, like in Vilnius in Lithuania, we have a temperature setting within the database which is calculated into -16.7, and for doing heat load calculations this temperature needs to be I think -23.4 or something. So depending on the location also the heat load is calculated accordingly. Well, setting up the building model for doing calculation is of course important, and that allows us to go into each different discipline, and I will start with heating in this case, heating on the ground floor. And when opening now the building model, the same building model is available, what we saw on our architectural model. But for some disciplines like ventilation, there are much more tabs or much more parameters available within this particular room. So we not only have the U value which is needed for the heat load, but we can also have heating facilities, and we can also calculate with radiator settings. Of course, the information from this space was derived from the IFC model, and we can also see the IFC properties inside here, so which are put in by the architect. They can also be read out by clicking or showing the information of this space. Well, in this demonstration for DDS-CAD on the sanitary discipline, I would like to show you some of the elements how we draw with sewer system. And sewer system is one of the difficult things in the way that with sewer we always apply a certain sloping. What I did is I prepared a part of my toilet area, and as you can see, we represent the sewer system by different lines. So we have the center line, and we can have, because of the object structure inside DDS, we can have different representations. So when we switch to single line view, this is our first setup of the pipe system or the sewer system. Because of the object structure, we know that a pipe on 110 millimeter will be used for our sewer system. We can also show in 3D, and another view which we can have is that we can have like a colored view, which will be represented on our top view of the building. So I'm using a section view on section AA, and this will give me a side overview on the slope which is set in this area. So we can see on the right side that we started with a sewer pipe, and because of the slope is going down minus 100, which means on every 100 meter the sewer pipe will have a slope of 1 meter. That means every 100 millimeter we have 1 millimeter. That will show us the pipe going down. So this is the endpoint of the pipe which we would like to be connected to the main pipe, which is on the left side of the building. We can do this in 3D, but we can also work in 2D, of course. And DDS will show me where to connect and where it can be applied. So I will start at the endpoint of this pipe, and because of the object structure, the endpoint can be continued, as can be seen, and we can see from our XYZ coordinate that in this case this pipe is going down in every step when we move it to the left. So I can say I would like to go from this point, and I would like to make a connection into my main branch. And because of the main branch is different in height, there is a delta which is showing like minus 0.54 meters, and when clicking, DDS tries to apply the setting. And when we show in our section view again, we can see that this is the solution that DDS come up with. And because we are the engineers, we decide what to do, we can alter and we can change. So when we don't want to have one band, we can exchange this to a T, or if we would like to have one band replaced by two bands with a certain distance, DDS will help us to optimize our solution. So this can be done directly by manipulating the different objects, and of course the representation, when I select an object, we can also have our 3D view, and then we can orbit around whether this is a good solution or not. And that's up to the engineer to decide. So it's not up to me to say, okay, this can be made, but what is the most optimum situation in this case? Furthermore, when applying from our sewer system on the right side, I already connected a urinal. When I take another option of the urinal by copying the object, by pasting the object on my mouse cursor, and I would like to have it 60 centimeters as an offset in positive Y direction. So this is my second urinal, and I can continue from this band making the connection. And for that I just have to start with Smart Start. DDS knows that this band can be replaced to a T, and we can start from the T and make the connection. And as you can see right now, the urinal itself also has a connection point available to our sewer system. So we can see we are starting after the T with DN70, but the connection to the urinal itself is set to a DN50. So what we can do, we can make the connection. We'll do it like this. And DDS proposes how the connection can be made. So depending on the object type, we can have a direct connection, or we can choose in this way. We can choose for a horizontal first and then going up in vertical direction connection. So right now we can insert after our T also a reducer, which allows us to go from 70 millimeters to 50 millimeters. And then we can see on the endpoint towards our urinal that also the connection is now changed to DN50. And this can be done very easily, of course. I will change to my other 3D representation, which is our render mode. When I select an object which is just connected, I can zoom to this object. So this is my connection from my T going with the DN50 in the out towards the urinal. So this was a manual connection after the T. The same manual connection is also used to connect this toilet, but we're also including inside DDS automatic connection functions. So when we select the toilet, we can use the connect selected object function. And for the sewer system, which is part of the drainage, we can say try to connect with a pipe into the floor. So we will recognize the horizontal sewer, and it will try to connect once again with the most common situation. So it's going straight out and then it's dropping down into a T like this. Another situation is that we drop down first in a vertical way and then have like a horizontal T connection. So this is all possible from DDS, and once we have a single connection, we can always extend this with a subcircuit, and then we can have repeating of such a connection. And if I now click inside this main string, there will be a second connection. Let's see, I will use this in a repaint. So this was not intended what I should think it should do. Let's see, then we do it the other way around. And this is always in a live setting. When you do something and it does not directly do what you think, then it is always possible to redo this. So if I use another repeat in the same branch, okay, then we have like, okay, well, this is not possible because of the connection which is already made. But for example, when I take this one, so this connection from the T can be copied many times. So when we have one toilet or we have two toilets, it will be extended. Because of the thinking in the system way, starting from the main string in this T part, when I select in 3D, we can also easily interfere with our connections. So this T part, which is in front with a part from the main string, and at the end there is also a part of the main string. When I now delete this T part with the subcircuit, this means this is towards the toilet, we can see that our main string now is merged into one pipe again. So the connection of this one pipe element allows us to influence the pipe system again. So when inserting a connection, automatically a T is inserted, but when we delete the T, then the main string is merged again. And this is quite nice to have, because in this way we can influence the system directly. So once more, making a connection from the endpoint, and because of the slope, this pipe will go up in our zeta, Z height, and such a connection, which we saw before with the automatic connection function with the floor in pipe, will show me automatically that this pipe, because of the small overstack of the main string, it is now changed to a band. So this could be like an endpoint of our toilets. Well, there are many ways of connecting objects, and it is always up to the engineer to decide what is the best way for making a connection. So right now, the information of this pipe element, if we put in article text, then I will put in article text on my pipe segment, for example on sewer system, we can determine what kind of information we would like to represent. So in this way we have a 100 millimeters in size. This is a part of 50. We can also identify which string this is. So not only the dimension is available, but we can also see what is the product number, what is the product text, what is our mounting height. We can activate the value of our slope which is applied, and this can be set as a value 1 to 100, or we can also have this represented in a degrees or percentage way. So this kind of information can be directly applied to each pipe element. So this is the height of my 10 meters, and if we apply the same text, for example, on this spot, we will see different settings here. So this is going down with 3 centimeters to 0.07 meters, but of course the slope itself is similar to the way we see the slope on this part. When switching to render modes, some other parts are already modeled. We also have modeled the connections to the story above. So as you can see here, we can easily say we would like to have a connection into, yes, of course. When doing the copy just, then the complete string here was copied double. So that was what was going wrong. So I will delete the complete system again. So it's not deleting just single lines, but we can delete the complete system. As you can see, I would like to go out on this particular pipe element, and I would like to have a 110 on 45 degrees, and I would like to continue with my let's see, sewer system, 135, apply. I get a message like this one. Okay, okay. So now I'm coming out with a 70. On this spot I can go to the left. So if I would like to move 1 meter to the right, this is 1 meter, also indicated by DDS. And with the right mouse click we can end in story below, but I would like to go into the story above. So what I will do, I'll make the connection on this spot to know for sure that the drawing direction is automatically set. So we can go into the story above from this point. I will delete this part of the element. So now I created an extra connection to my story above, and the story above from this point can be recognized on the story above inside DDS. So when going to the project menu and we activate the second floor in our heating system, we can see and also use the same coloring to represent also the connections on the next floor. So in here, what we can see on the center is a connection which will show me the information and connections to the floor above. So this is also now part of the system with the connections available. So it's not just modeling in 3D, but it's also modeling in information which consists of the entire system. Right. In this model, not only sewer is selected, I I can activate in my pipework discipline, I can activate all my other layers which are already in. Let's see, I will take this one off. So inside this model, there is a lot of information. So this model was created by one of the Dutch companies, which will provide not only sanitary systems but also integrated cooling systems. And I'm trying now to see my cooling on the ground floor, so I will deactivate. As you can see right now, when selecting the sewer system as a pipe for the main branch, we can have different groupings. So heating, sanitary, domestic, also fire extinguished, and steam as a medium type, as a fluent can be used. And within domestic water, we have different medium types. And each medium will have its own representation. So when I start, for example, rainwater, it will show me a specific element pipe in blue. When I start a cold water system, then we switch to sanitary cold water. Then the material is also changed to copper. So automatically for sewer we apply plastic, eventually with high temperature, and for sanitary we will start with copper. And creating such a system is very easy. And changing the system, like, okay, this was not intended to be cold water, because of the green color I can see it is cold water, but I can also change this easily to a hot water system and just continue on hot water. So the system is intelligent to know from the start point where I started, there is a specific medium type, and when I change the medium type, automatically the rest of the system is also changed accordingly. So we can easily interfere and change the system when doing our designing. Of course, when selecting the circuits, we can also have a parallel circuit. So we would like not only to have cold water, but we also would like to have hot water to the right or to the left. And if we apply also like circulation water, then we can have a different sizing of the distance in between of the pipe elements. So what I now did was a pipe element on 1 millimeter. I will try again, selecting the circuit, applying a parallel chain, and then I will apply to 10 centimeters, and we can see directly what is causing this. So we not only have cold water, and I think that cold water is turned off by the layer. Yes. So I will turn on like this. So in my 3D view, we can see the coloring applied to green, red, and purple for our circulation. And this is what we think of in a traditional way by representing a pen color. But if we change to our render shading, we apply the materials which are used to these pipe elements. So when I go once again to my last drawn pipe, which can be found here, we can see the circulation, and there will be a clash. So this is a visual clash, and this is very nice to see, of course, but inside DDS we also work with clash prevention. I will turn off my layer on texting. So once again, starting with a specific bend, I would like to have a T part which is used as a branch instead of a T part ahead. And when selecting such an element, we just saw before that we could connect a sewer pipe to another sewer pipe, but it is impossible to connect a hot water pipe to a cold water pipe. So DDS will recognize there is interference on the same height, there is no offset, no delta, and DDS proposed to have a clash avoiding by using a step over this pipe element or a step under this pipe element with an automatic function. So when I go underneath this pipe, we can continue on the other side, and the result is quite nice. When looking in 3D, we can see automatically, yes, of course, my cold water is turned off again. This can be used as a preset. So my hot water system will now drop down to a lower level to avoid the clash which was caused to the cold water system. So this is done automatically when doing the design, and of course this clash on this part will also be recognized, and that needs to be solved, and that can be done in different ways. One of the ways is that we delete the T part. We set up that we would like to start 10 centimeters higher, and we would like to make a connection from this height to this height, and then automatically, because of the connection of the same medium type, we are able to do a, let's see, we're able to avoid the clash. By the way, okay, now I will save my layers so they don't turn off every time. So this clash was seen visual and can also be recognized by DDS by using a clash detection. In this pipe element, the clash detection is recognized that we also have open ends, for example, and we have really physical connection with a clash. So, for example, if we have a clash in sewer system, we can use zoom object to see where is this clash located. So in here, apparently there is a clash, and it can be recognized by the software, but it can also be recognized by us. There is a hard clash, and we can also visualize soft clashes. So this is what I changed before, and now I can have my layer setting on, yes, on pipework. Save, save, okay. So because of the connection which is available from cold water to cold water, DDS will automatically recognize the difference in height and select a possibility to connect the pipe elements to each other, avoiding or solving the height difference. I will show you from my T, if we would like to have the T changed in position or changed in direction, we can move the T into the string. So when we select the T and move it, we can see that this pipe element on the background on cold water is changed. And if we would like to have another placement, we can select our bend and we can move the bend into the different directions. So if we would like to have it here, or we can have a parallel offset like this, or like this. So we can be very creative on doing the modeling part. All right. We saw that from our section view, we applied the connection from the sewer system with the slope to the main branch. We created some connections to sanitary elements. So we connected upward slope the toilet at the end point of the main branch. We also activated or connected a double urinal which was connected. So this is now part of the system which can be represented in different ways. One of them was the coloring of the flood fill of the elements. And this will give us an overview with lots of information. And we try to select the information and put them into plots like traditional way. So I prepared a plot, and in the plot you can see what I would like to show to my end customer. And the plot can also be like a summary of the model itself. And in the sanitary elements, I created a plot for my sewage system and also for the heating and also underfloor heating in this element. So the plot itself, if we are now representing the text, we can have many ways of this text. And I created also a PDF of this sewer system. So if we open up the PDF, we can see like a more clean view of this this segment. So when I zoom into this particular spot, we can see, in this case, the dimension is set with a millimeter sizing, and on the same plot there is also the section included, this one. And there is also some other information included. So from the kitchen interior there is a PDF inserted into the plot, which is now represented, and also the designer of this model included an isometrical view, which also show me the information of the sizing of the pipe onto the same plot. Well, as well, the information from the project itself is also listed into this plot. All right, we saw in 3D that we can also activate it ghost modeling. And ghost modeling means if we activate different stories which are in the same project, we can have like a surplus of each building story in one step. Now we'll show this building model. No. So as you can see, this is the complete sewer system, and when I now activate also my pipework, we can have an overview of the building model. And what I turned off was my architectural model. So I turned off the flooring, I turned off the wall, so I can look directly into my building model. And this will give me a quite nice overview. Well, of course, also what Mark was mentioning, it's not about the picture, but the picture needs to be complete. So when a connection is needed, also the connection should be applied from the source. And we can have a selection of an object. We can also have the sectional view. One of the features inside DDS is that we can also apply clipping. So if we would like to open up our building model, we can push the model into our riser pipe, and we can investigate whether the connections are okay or whether the connections are not okay. And as you can see here, there is also a distributor included, and with the distributor we have some valves. Some valves are also going up. In this case the valve is connected to, let me see, this is a distributor, and the distributor provides information for my cold water system. So this is a valve inside the main branch of the cold water distributor. This kind of information can also be captured as a BMP file or a JPEG file, which can also be included into the plot. The output of the plot or the output of the model can be done in every way. So either we can export this file in different file formats. We can have DWG or DXF files. We can also export to 3DS formats in order to make it like a more visual representation. And of course we can have the export again to IFC format. And that is something which I would like to show you at the end of this, this presentation. So basically the functions of DDS on sanitary are equal applied for ventilation, and that is my next step. On ventilation, we are completely different in a way that the building itself also needs to be ventilated. So when looking from the same dialog of my building, from the room information, we can now see from the room list in our airflow requirements whether the space needs to have a supply or needs to have extract air, for example, for my toilets. So we can now see the toilets, the kitchen are set to supply. This is not correct. So what I can do, I can search for spaces, and when I search for the spaces, toilets, and my kitchen, we can determine that these spaces are part for my required airflow as an extract room. So that will be applied also for the air design inside this space. This can be calculated from the ventilation demands of the space itself. So right now the spaces are changed from supply to extract, and in our airflow requirements room list we can now see the kitchen and the toilets as expressed as extract air rooms or spaces. Okay, for doing the calculation from the building model, my airflow requirements are calculated for the entire supply air and also for my entire extract air. So we're now doing the calculation. I did some changes in the extract air, and DDS is also telling me you applied for specific spaces. For example, this room, this is the room of the bar. There are no terminals inside. So there is a demand for extract or supply, but there are no terminals. So that is something for me to look into, like zoom object, which we also saw before in sanitary. So this is my space, which needs to have supply or extract, but it's not provided yet by a terminal. So that's also something I'm connecting. So what I can do is I can put in, or I can start with a terminal. So this is a terminal which can be set in the bar or in the space of the bar. We can have another terminal which is 2 meters to the bottom, or if I would like to move an object, we can easily move it by corresponding parameters. So this terminal is set with a specific airflow, and we can once again start by connecting from a bend, and now the bend is also recognized and can be changed by a T, and afterwards I can start from this T with my ventilation system. So this is my ventilation system, which is a 550 by 250 duct. So this is a rectangular duct. Well, I need to go a little bit further than these columns when it is a column. And yeah, I would like to make a connection to this terminal. But when I look to this terminal and start from the terminal, we can see there is a connection from supply air on around 200 millimeters. So what I can do, I can say I would like to make an automatic connection to my kennel. It could be directly or it could be connected to the top. So now this is connecting in the same way that we use the connection function on sanitary elements. So when I select the object and switch into 3D, then DDS will show me automatically this is a connection which can be applied like this. But this is not something I would like to have. I would like to have a different sizing. I know from my experience that here we can have a reduction on my pipe element. So instead of 550, I would like to have 300 by 200. So now we can see that the rest of the system is now changed also to 300 to 500. I will put in some text, and the text will show me also the sizes of this element and also the velocity and pressure. And the transition from one rectangular duct to another rectangular duct, I would like to change it to a round duct. So then I would like to have my reduction to a 200 millimeter, 125 transition. So I changed the system by rectangular with a saddle connection, and now I changed it to a 200 millimeter connection. We can do the same thing. Say this can be deleted, and I would like to have this T, which is also a saddle piece, changed to a bend. So now this part is changed to a bend, like this. Then one of the next steps could be that we will insert a damper inside this element. So the damper is also part of the system. Cancelled my damper, then I click OK, and after the damper, many times there will be flexible circuits. And flexible means that it is flexible in a way that the terminal itself can be moved. So we started all right. My DDS is stopping in this way for a second. I will quickly restart DDS again. Sorry for that. Let's see my DDS. So because of a live setting, this can always happen. Of course, I'm doing quite some changes in the model. One of the features inside DDS is it is object-based. That means that in the background there is like a database structure, and with the database structure we can always put back the situation before the crash or before stopping of the program. So right now there is a backup which is now opened in the background, so that means I don't lose all of my work. So DDS is trying to open up the project again. I will open up the ductwork. It is now reading the building model from the IFC. And then I will open up my ductwork. Yes. So just before entering the parameters on the transitions, I can make a small transition here to 300, 200, and the other transition which can be applied could be a connection from or connection to round on 224, for example. So this is my transition, which can be set to 125, and instead of making the connection to flexible, I will make the connection directly from this endpoint upwards to the terminal, and now with a direct connection it is also lowering the bends in order to have the same height of my air terminal. So once again we can have the damper inside with OK, and then afterwards we could also apply the changes for this system, which is now folded spiral. We can also have the folded spiral changed to flexible by doing this on 224, for example. And then we have another representation when I turn off my coloring. So we can have a representation on the flexible pipe element with the damper in here. So same thing on the endpoint here. We can have a general T, and with the general T we have a dimension of duct, and I try to make the connection like this, and DDS will show me or will apply the changes in here with rectangular. Well, if the connection cannot be done rectangular, we can always change and have my 125-224 millimeters inserted in here. And we can see that the rest of the system is changing directly from rectangular to round in a click. Well, for doing ventilation, we applied a specific amount of airflow on extraction. And if I would like to calculate, or I would like to have my room space calculated, so we can see from the required airflow, there are two terminals now inserted, which are now connected. We can calculate the sum of results on the airflow. So when I go to my start point of the string, which is coming from the floor above, we can create a calculation point which is called air supply, and within air supply we can calculate the options which will show me the strings which are now used. So we can see on the right side which element of the string we are talking about, and we can also see the dimensions. Well, I will take one step back. For doing the calculation, I first would like to show you the levels that we are using for this calculation. So I will turn on my coloring mode, and then I will turn on the level view. So let's turn this one off. Extract air klima. So the start point of this system for making the pressure loss calculation, we will have a maximum of 6 meters per second for this element. That means if we have the level view, let's see, okay, yes. We can have the level view, which is now set to 6 meters per second, and the level view could be changed. For example, after the transition, we would like to have a different level view. So instead of the 6 meter, we would like to calculate to 4 meters per second, level 3, or we would like to calculate to level 4. And when I now change my pressure loss calculation, this is like a preset on which the system should create or should optimize the calculation. So we can see in red, this is now not showing the red coloring for supply air, but this is showing that we would like to calculate to a maximum of 6, and the blue is showing us that we would like to calculate to a maximum of 3. So this is the setting. And if I turn off the setting, we will see everything in red, and then I will start my calculation. My calculation from the start point is now calculating the velocity inside the system itself. So we can see in the main string a result on 2.8 meters per second on velocity. And when I apply these settings, we can have a view to the results in coloring on calculation color. And this will provide us information that within the green color, everything is set accordingly to the level. This will mean that this one is set to 6 meters per second. And when I double click on the element and investigate what is the actual pressure loss on this element, for example, then we can put in article text again with the round rectangular duct, like the speed or the pressure in here. So there is, well, quite a low amount or pressure loss on this point. But if we now increase, for example, the amount of airflow from 50 to 300 meters cubic meters per hour, which is needed inside this kitchen, and we will recalculate. Then we can see what kind of influences are with this new situation. So instead of 2.6, we are now facing 3.8 in the main string. And let's see what now the results will be. So everything is still inside boundaries. Let's see if I change this reducer, I put it in here, and then I'll make a reduction to a much smaller pipe element, like for example 200 to 100, and rerun the calculation again. Then we can see directly what is causing changes. So we go to this calculation. Well, somewhere we are facing a velocity which exceeds the maximum. We can zoom to the selected object. So now, after a very small transition to a different pipe size, we will now exceed the maximum velocity which is set in this string. So now this string will be marked as red. And this will give us a very good and clear view on what can be modeled and what cannot be modeled. So every change on the end of the system, whether it's the amount of airflow which is required on the terminal, or the influence from changing a transition on the front of the system, will directly interact with each other. And that can be seen directly not only from the calculation as a result, but can also be represented in a more graphical way. So when we do the normal designing, everything is red, but we don't know yet if it is okay until we do the calculation. And when we see the calculation colors by results, we can see, okay, we have a problem in the red area. Or we would like to optimize, for example, this element on the top, it's quite big in size. And if we look to the text for our velocity, maybe we can decrease the amount of air, or we can decrease the actual size of the duct. Well, 2.6 is quite nice as a velocity. So changing a transition on the front of the system will also influence the T part, which is applied in here. Changing a transition from here to round to duct, rectangular duct, can be done directly, and also the calculation can be done or can be executed again. So we have the 250, and we can rerun the calculation from our pressure loss calculation on the air supply. We apply the changes, and now we can see again that our system is back into green, which means this is okay so far. If we connect other terminals, then of course we have to recalculate, and that's the part. We start with something, we calculate, and then it will extend into more detail. Well, also for this part, I prepared from my ductwork also extract air and extract airflow for the climatization, and showing this in 3D in our render mode. This is now with the building story on, so we can now also see this is, I think, a suspended ceiling. This is the IFC covering from the architectural model, and if we turn off the architectural covering, which is in the basic geometry or in building, covering like this, then we can also look inside our model. If we would like to investigate, for example, the location around this riser pipe, we can also select an object and say we would like to clip away and investigate. So this is a basic function I showed you on doing the clipping manually, but we can also select the object and use the clipping away. And as you can see right now, this is coming from the story above with the reduction, and this is okay for a visual clash because these pipe elements also include with insulation. So we can have like a little overlap on insulation, or the insulation can be taken off, and this can also be seen in 2D. So if we have in a part of an element, so for example I will take from here, I will take a saddle piece out, and from the saddle piece I would like to apply insulation in a specific part of this, this duct. So what I can do, I can say insulation from this point on, like 50 millimeters, and it should be applied until this point, and then I can turn off the insulation again. So only this part is now insulated and the rest is not insulated. So we can be very flexible. You can see in gray also the calculation color, which means it is not calculated yet. I can also extend with a specific load. So for example, if I don't know exactly how many terminals I would like to have inside one room, but I know from experience it should be 550 in cubic meters per hour, we can put in a load, and this will represent 1, 2, or many terminals. Once again, going to the calculation in the pressure loss, then also this string will be calculated. So we can now see this is turned into green, and I would like to show you some other thing. If we put in a calculation point here, and this will be a test calculation point, I can also have something like this. So my actual status is, it is a duct on 300, but from the calculation when we add transitions, it will stay 300. That's nice. But it will change automatically from 300, it will change to 200 because of the load. So I get some message about layers which I turn off. So the load will show me that when I put in transition, we can have a 200 millimeter duct instead of 300. That means DDS will tell me that the minimum size for the load, which is now applied on 550 cubic meters per hour, could be reduced to 200. And that is something in which DDS is very, very strong of. So the saddle piece is still 300, and because it can be reduced to 200, DDS will insert a reducer. If I turn off the reducer and I will change my saddle piece, instead of 300, I will change it to 200, and I also lose my reducer, and the rest of the system will also now be changed to the new dimension 200, and this will be the result in my, my airflow calculation. Okay, similar to the PDF, there is also this PDF created, which is represented with single line schema, and the single line we can also see the terminals with flexible pipe, and on the right side in this PDF also a small isometrical or 3D representation is also inserted, as well as the detail. So this can also be derived from the model directly, with or without a building model, with or without, for example, a specific section or a specific part model of the model in which we can also work. So this is like a summary of the second discipline on ventilation, and our last discipline, electrical, which I would like to point out to you in this demonstration, is a prepared model in which we have a render shaded, and we can also see inside the building model. And in this way, I will change my render mode to render cartoon, which will represent in a different way. I will turn off from my layer my covering, so I can look inside the building itself. And whether we draw a sewer pipe, whether we draw a ventilation duct, whether we draw a ventilation canal or a round tube, the principles are all the same within each DDS discipline. So what you can see here is a cable tray. From a cable tray we can start again, for example on this T or this bend here, we can start with a cable tray, and from the endpoint of the cable tray we can continue with a T as a branch or not as a branch, and then we can continue also on the other side. If we would like to go up, we can say I would like to go up with a delta, which will result in an absolute value depending on the height which we started. Or if we would like to start from a specific height, we can also move page up and say I would like, or page down in this case, I would like to go to the certain or the absolute Z value on 3 meters. And then I would like to make a connection in here, or go underneath this cable tray. So this cable tray can be done on different heights. So now it's set to 4 meter 10. If I change it to 5 meter 10, we can see the rest of the cable ladder is extracted in Z height. But of course, where we drop down to our height of 3 meters, it will be intact. So we can manipulate the system, we can stretch, we can move, we can do a lot of things on the system, and this can be done on every discipline. So we don't have any problem in the cable ladder on this section, and of course 3D is much more easier to work with. Because in 2D we cannot determine that this would be a connection or a clash, or which one is going above, which one is going down. So the 3D will help us in different ways, in different manners. So the width and height are extracted from the model, so we can see 390 to 3 meters. So if we need to move something, we have 90 millimeters available space to put this one up. If we take it up to 3 meters 30, then we can directly see also the part text is changing immediately. So one is directly related to another. So it's really extraction of the information. Okay, on the electrical part, I will show you some of the elements which we put in. Electrical is very specific because in 2D we have a symbol, but in 3D the symbol represents a physical object. So the symbol for, in this case, a socket, which can be changed from a flush-mounted double to a 4-way horizontal. So this is represented by a symbol, but when looking to the physical object in 3D, we can see directly the object. So this is our socket. Well, the socket can be connected to a circuit board, and the circuit board, which we already applied, is the main board A001. The same can be done for this connection, but it could also be connected to different groupings. So in electrical we also have schemas for this board, and one of the boards we have is a board which will include a main fuse on the top, like the power in of this board. Then we have one-phase circuits going out. So this is like a single phase end circuit which is connected to L1 and the neutral. And this fuse 2, or the circuit number 1, is for lamps, spots. Circuit number 2 is general light fixtures. And so this is like a preset we have inside this this diagram. So we can connect the sockets to a specific grouping, and if we have an overview of the circuits which are here applied, we can have lighting sockets, lighting circuits, and starting from 24 we have power outlets or power sockets. So we can have circuit number 32 connected to these two sockets we put in, and that can be done like this, connected to the HDL V on 32. We can also see the name of the room in which now the object is located in, and if we turn on the information once again from the text, we can have the mounting height from the text, and if we apply a reference line to the object, we can always identify where this object is coming from. If we move the object like this, or if we move the text like this. All right. So this is one part of making the connections and applying them to the different sockets. We can also start from the main distribution board. So when we search the object, view, this is our main distributor. We can also do something different. So if we connect this one from this socket, we can say from the circuit list, I would like to have a cable drawn as a circuit from my distribution box. So at the end point of my box, I will go inside a wall, I will go into the direction of my socket, and I will connect my socket to the cable. And if we now see in the distribution overview, we can see the cable is now drawn with a length of 0.6 meters. That means in our bill of quantity, we can also have this cable now available. So we have PVC cable, which is now set to 0.95 meters. So the cable itself is 60 centimeters. We have 20 centimeters on the connection side and 20 centimeters on the other connection side, which will be added into the bill of quantity. If we double click on the cable, we can see the dimension of the cable, and we can also put in the load of this cable. So whether we have a socket which is specific for a big icing machine, which draw up to 2 kilowatts, the 2 kilowatt will influence also the load inside the cable. So 2.3 kilowatt will draw 10 amps. And switching to the representation in 3D, let's see the 3D. We can have the cable also represented in 3D with a dimension which is applied to 1.5 square millimeter. If we turn on the conduit, we will also have the conduit with a specific dimension which will show the size of this cable in a little bit thicker way. So I will extract once again the bill of quantity. And this is for the entire model, so all the information is now gathered, and we can represent the cable and the conduit together as a different object from the bill of quantity. So we have two-way sockets, 14 in total, and what we showed before in the heat load calculation to the report, we can also have a part list, a bill of quantity, which is extracted per room. So the bill of quantity will read out from the building model in the applied objects. It will read out the room list or the bill of quantity dividing into the different rooms. So the information is now also gathered from the model, and I will continue in my model. There are quite a lot of objects on electrical. So this is a predefined report in which we can see that in the room with the entrance, we have these elements. On room number 2, we have different spots, different lighting types, so emergency lighting, we have double socket, single sockets, we have a dimmer function, and this is a predefined report which we can also export directly into Excel. So when I save this one as Excel, or I can put it to PDF of course, I can also put it to a comma separated file. But when opening to Excel, we can also export in Excel different pages for each page end from the entire report. And then we can also edit in Excel this model or this document again. So now it is exported to Excel, and I will continue on my building model. And as you can see the model itself can be quite extensive. The amount of air fixtures in this model for a specific article, there are 18 articles with the same article number. And if I search, for example, to this, let's see what it is. This is a incandescent light fitting on 35 watt on 3.8 meters. If I select the object and would like to show all articles, we have in total 41 elements. If I click on edit, we can see that the height is different because it's not inserted here. But if I select one object and do, instead of the same article, I would like to have equal objects, then only the objects with the same height, 3.8 meters, are now selected. So from the 41 elements in total, there are 38 elements with the same height, the same layer, the same article number. And that allows me to change for specific articles. So if I would like to have a lamp fixture which is set to a criteria on 3.8 meters, then these lamp elements, 80 elements in total, are on the same height, 3.8 meters. So I can search very quickly into my objects to determine are they equal or are they not equal. And if I would like to change all double sockets to single sockets, then I can select. Let's see, is this a double socket? Yes, this is double socket vertical. I can directly, in one instance, all articles, well in this case I applied only one, I can change it, instead of vertical, I can change it to double horizontal in one click. So my bill of quantity is now up to date, but also the model is up to date. And this is very powerful when doing object-based, in which also the objects are connected with cables. So when I move this socket from one side of the room to the other side of the room, we can see also that the cable is now extended, not only in the bill of quantity, but now we also have to search or to see in 3D, can this be done or not? So we have the socket in here, but there is also a cupboard inside. So when I now measure the height of the cupboard, so it's 2.277, then I need to have at least the height, for example, 3. So not only the object is now moved to 3, but also the connection with the cable is now extended. And if I would like to have the cable differently like this, with 2 extra bends like this, for one reason, then my cable length is exactly what I created. So I can have a cable drawn directly, or I can move such an object like this, in which the cable is also changed in size, not in size, but only changed in length. So on 3D working in electrical, we can see lamp fixtures, we can see light fixtures, we can see sockets, we can have fire detection. One of the nicest things is that we also have a fire detection area. So depending on the size of the room in relation to the angle of the roof, we can have different circles which represent which detection area is inside. So we can have a circle in this room which show us that on the top side of the room in here we don't have a covering area. So at least 2 circles need to be inserted like this to have a complete overlap. So this can also be done a representation. Also on electrical, I put in a plot layout which is this one, and in this case there is also a picture included of the existing distributor. So this is an actual picture, so it's not a render. This is the current situation, and this project is done for refurbishment. So also the existing components needs to be taken care of. So this is the same plot layout what I created, like the PDF. We can add in a legend. We can also have the complete layout exported once again to traditional 2D. And we are also capable of exporting to 3D DWG file. Well, as promised, when looking to the model and doing the export of the complete system for the different disciplines, we can extract not from the building model, because the building model is also already done by the architect, but we can extract our ductwork, we can extract our heating system, we can extract to IFC. Let's see my sanitary, yes, for all of the stories. So when this is done to an export of IFC file, it will gather up the information. So right now the IFC is already created, and which I can show you together with the building model. So when I turn off my building model, and then we come to an end of my presentation, and we will have time for questions or specific topic handling. When I add my IFC file, which is derived from the DDS model, we can see, well, quite similar coloring. So my ventilation system is starting from the top of my building, and we can identify by double-clicking on an object that in this case the object is belonging to supply air. And double-clicking on the yellow one, it will show me that this is extract air. And one of the nicest things in IFC is that we can also identify the systems which are used. Because of the calculation, we can have extract air as a system, and we can see directly by selecting the extract air from our exported IFC file which belongs or what belongs to extract air. If we turn on the exhaust air, we can have also the supply air turn on. So we can identify from the model, also from with the Solibri viewer, we can turn on the systems. This is quite a nice feature. So I will turn on the complete MEP system like building services. And when I now turn on the elements from my story, so when I turn on the spaces, we can also see the spaces we also saw before in DDS, with the technical information or the technical requirements are now visible. When we turn on the beams, or we would like to turn on also the curtain wall on the outside of the building, then we can have slabs, and we can identify whether we have clashes inside our riser pipe or not. And well, the best of two things come together. So the modeling is done in DDS. The optimization, the calculation is done in DDS, and when we double click on such an element, we can have also the information, what kind of system it is, to what system it belongs. So the information we are creating is very redundant, and if something is changed in the model, we can extract or export another IFC file, so that can also be used for versioning control, etc. So this part of DDS from the presentation is well, finished on my live setting. I will now turn on from electrical my ground floor in the same model. I will do the same on heating. I will do the same on cooling and on ductwork. So now the disciplines inside DDS will be visible in one merged file, similar to what we saw before also from the exported IFC file. And this will give the opportunity also to have some questions. So if there are any questions or any specific topics which needs to be clarified or verified or showed, then please raise your hand or type in a message. All right. There is a question about the bill of quantity. The bill of quantity, can it be exported for each discipline? I showed in the demonstration, I showed the bill of quantity extraction. And in the extraction of the bill of quantity, we will show what is on the screen. So if we turn on, for example, from the installation model, when I turn off the layer of my, let's see, where are we here? My lamp fixtures. So when I turn off every layer, only the layer for lamps is now turned on. No. Then with the bill of quantity, we will extract only the objects which are now visible. So the layers that are turned off or are frozen don't show up in the bill of quantity. So these are the settings we can have from the lamp fittings. Also there is, with the print report function, there is also a part list for quantity survey. So we can also have a different representation of the elements which are belonging to different disciplines. All right. I will turn on the report. And then I would like to ask Carolus if he can join in for the end of this presentation. So
yes, good, Sam.
Yes. So for my part, I'm happy to show you the possibilities of DDS. The possibilities are not only CAD drawing tool, but also extracting information, doing calculations. Right. So from my part, I would like to thank you for attending this online webinar. Mark and also me, and that will also count for the rest of the guys, also from IBIN and partners. Would like to welcome you again in another setting or in another demonstration. So Carlos, if you also thank you, and maybe you can say thank you to the rest of the visitors. And if there are any questions left, the questions can also be sent by email, and then they will be replied by us.
Yes, of course. Thank you for the presentation, Gilchan.
You're welcome. So I would like to thank everyone for attending, and hopefully to see you in the next time. Thank you. Bye bye.